So, welcome, 5D.1, we're talking about applications of the unit circle, and so we're going to be flicking between this page and the page in which we drew our unit circle on. We're going to need to be getting some numbers from here. We're going to be looking at that, we're going to be getting the numbers, and then we're going to be applying it here. So, here we are. First one says, find cos theta, given sine theta is root 3 on 2. So firstly, I've just drawn up here some things for us to remember. X is cos theta, y is sine theta. Brad, just sit down. I want you to listen to me rather than having a look there. We've got the sum of sine and cos squared is 1, and then we've got tan theta is sine on cos. So we're told this, sine theta is root 3 on 2. Okay, and I'll put that in my calculator. I press the search decimal button, and I got, well, to 3 significant figures, that's 0.866. Okay? So remember, sine is the y values, isn't it? So we've got a y value, that's going to be somewhere along the y-axis. Here is y is 0, and here is y is 1, because it's a circle with a radius of 1 unit. And so 0.866, probably about there somewhere, isn't it? Okay? And so the question is, what are the x values on the unit circle given the y value is 0.86? So if that is 0.86, the corresponding values on the outside of the unit circle are going to be here and here. And so that's where we can flick over to our unit circle, and we can see here we've got a y value of root 3 on 2, and here we've got a y value of root 3 on 2. And the question is, what is the x value? What is cos equal to in those positions? So let's have a look at our circle, and we've got half and minus half. Okay, and we're going to notice these kinds of patterns, right? It's got the same y value, the same height, and the distance from there to there, the x value is positive half, and from there to there it's the same distance, only it's in the negative direction, so that one's going to be negative half. Okay, so that's our answer to part A. Alright, part B. Find sine theta given cos theta equals a third. Okay, that's all the information we are told. Now there's two processes we can use to solve this. Okay, and you can use whichever process you prefer. I'm going to go through both. The first one is this equation here. Alright, I'm going to take that and put it here. We've got sine theta squared plus cos theta squared equals 1. And I'm not writing it in the correct manner, because in a moment we're going to do some substitution. Okay, I've just rewritten that statement. We've got cos is a third. Cos theta is a third. So I'm going to substitute that third right where the cos is. So we've got sine theta squared plus a third squared equals 1. And then we're just trying to solve this for sine theta. This is the variable we're trying to get by itself. So we can evaluate that first. 1 on 3 squared. Let's do that up here a little bit. So 1 on 3 squared. If we remember back to index laws, that's 1 squared on 3 squared, which is 1 on 9. Okay, so when we simplify this, it's going to be 1 on 9. Okay, we want to get sine by itself. Okay, so we're going to subtract 1 on 9 from both sides. 1 take 1 on 9. Now, you can just put that in your calculator to get the answer, but let's talk about some fraction operations up here as well. We have 1 take away 1 on 9. If we're going to perform this, we need them to have the same denominator. So 1 we could express as 9 on top of 9. Okay, 9 divided by 9 is 1. All right, and then we have 9 take 1 at the top. Okay, we're going to have 8 on 9. All right, that's primary school fractions now, once we've got the same denominator. Brad, you're talking over here?
Yeah, where is square go for the sine?
So that needs to stay there. Thank you.
Yeah.
Yep, that should definitely still be there. So then we've got sine theta squared is 8 on 9. Okay? Now we know if we want to get sine by itself, we just need to get rid of the squared. We're going to square root both sides. So that's going to be the square root of 8 on 9. Okay. Now we can leave our answer like that, but our textbook might present it a little bit differently. And so I'll just give you a very brief introduction to surds here. With square roots, square root of 8 and 9, we can write that as square root of 8 on the square root of 9. Okay, so we can divide the square root. And if you put square root 8 in your calculator, I won't go into it now why, but that'll come out as 2 root 2. And square root 9 we know is 3. And then the other thing we need is plus or minus, okay, in our final answer, because when we form a square root, we can have a positive answer or a negative answer. So if you leave your answer here, okay, you'll get 4 marks, all right? However, if you did put that in your calculator would spit it out like this, okay? 2 root 2 on 3. All right, so these are the exact same number, just different ways of representing them, the exact same value. Okay, so that's the first process you can use. All right, is you can use the equation sine squared theta plus cos squared theta is 1. Now, I might show you the different. I won't repeat the same question because I can show you the different process, the alternative process in the next question. Okay, so we'll go ahead and do that. So, Ollie, turn your music down, it's too loud. I can hear it. Alright, so then we've got find the exact value of cos given sine is 2 on 5. And this time we're given a boundary, which is interesting. Okay, but I'll talk about the boundary right at the end. So we're going to find cos given this is the value of sine. So what we're going to start with for this one, alright, so if you wanted to, if you're comfortable with this process, you could just repeat it like that, okay? You could go through, put it in the equation. This time what we're going to do is we're just going to draw a triangle, a right angle triangle, and we're just going to put a theta in it, and we're going to put a right angle in there, and we're going to go ahead and label it. This is our hypotenuse, this is our adjacent side, and this is our opposite side. Now we remember from SOHCAHTOA that sine of theta, alright, is equal to O on H. Okay, so 2, see how here we've got 2 on 5 and O on H. 2 corresponds with O and H corresponds with 5. Okay, and now we've got this right angle triangle, looks like this. We've got 5 and 2, and we can use it to find this side. We can use Pythagoras theorem to find this side. Alright, let's call it A, because it is the adjacent side that we're trying to find. And we've got A squared plus 2 squared equals 5 squared. Alright, that's our Pythagoras theorem there. This side squared plus this side squared will equal the hypotenuse squared. And let's go and evaluate that. Right, subtract 4 from both sides, and then square root both sides. We're going to get A is plus or minus the square root of 21. Now, generally we don't consider negative lengths, right? You can't say, well, a length can't be negative. But for these purposes, this is an abstract triangle where we're considering the direction of it, and we're considering the unit circle. So we do need to include plus or minus. Okay, so we've got our value for A. Now, we're asked to find cos theta. Now, cos theta is, we know from trigonometry, is A on H. Now, we found A. A is plus or minus root 21 on top of H, which is 5. So that's the alternative manner we can use, the alternative procedure to find cos theta. We can draw a triangle, label it, put in the information we know, find the piece of information we don't know, and then go cos theta is A on H. Now there's one more step for this one because we're given a boundary. And the boundary is between pi on 2 and pi. See how in the question it says 4 pi on 2 less than theta less than pi. So in our unit circle, what that means, this angle here is pi on 2, this angle here is pi, and so it is talking specifically about this region. Okay, so it's referencing it to one region. And in this region, this is probably a good time to tell you guys about this. Okay, let's go through all of the regions. In the first, we call them quadrants, and we go in this order: 1, 2, 3, 4. Okay, in the first quadrant, both the x value and the y value are positive, aren't they? So both sine and cosine are positive, which means tan will also be positive because tan is sine divided by positive divided by positive. So in this one, we have all trig ratios are positive. Okay, over in the second quadrant, we've got the x values are negative because they're left of the y-axis, but we've still got all y values are positive. They're still all above the x-axis, all the y values. So we have all sine values. All sine values are positive. Okay. In the third quadrant, both the cosine values, the x values are negative, and the y values are negative. Okay, so they're both negative. But then tan, remember tan is sine divided by cos. So that's going to be a negative divided by a negative. So in this region, tan is positive. And then in the last region here, we've got positive cosine values. X is positive, but y is negative. Okay, so only the cosine values are positive. And so the acronym, who can remember the acronym? All students talk. I don't know, come up with something. All silly turtles crawl, all right? Now, all trig ratios are positive, sine's positive, tan's positive, and cosine's positive. Okay. So all that, okay, like that's a mini lesson in itself. All that just to say, here we need to get the precise value of cos. In this region, okay, only sine is positive. The region we're talking about, only sine is positive. That means the cosine value is negative. So therefore, our answer is minus root 21 on 5 because of the region we're constrained to. Because pi on 2 is less than theta is less than pi. Because of the region we're constrained to, our answer has to be negative. Okay, so they're the two procedures we can use. Excellent. Let's do, we've got two more, we've got D and E. So let's do this order out first to give you an opportunity to finish there. Okay. So D here, we've got tan is, find tan, given cos is 1 on 4, and then we've got a region, 0 less than theta less than pi on 2. Okay, so this time we're talking about the first quadrant. So, which process should we use? We could use either. Let's go with the equation. All right, let's go with the equation again, and I'll do it a bit faster this time. We've got sine squared theta plus cos squared theta is 1. So we're going to rearrange this to get sine theta. Now we're asked to find tan theta, aren't we? All right, but tan is sine on cos. So if we're asked to find tan theta, first we need to find sine. So that's what we're going to do here. We're going to find sine, and we're going to use that to find tan. So let's plug in cos. So we've got sine squared theta plus 1 on 4 squared is 1. And that's going to be 1 on 16. Plus. We'll subtract 1 on 16 from both sides. Square root both sides. And then we consider the region. Okay, let's consider the region. So I've moved very quickly there. All right, we've done it once already, and so I did detail those fraction operations and the squaring and this here. Like if you put square root of 15 on 16 on your calculator, it'll pop out with that for you. Square root of 15 on 4. Okay, So let's consider the region. So here's our unit circle, and if it helps, draw it. And we're talking about between 0 and pi on 2. We're talking about this region. And in this region, all ratios are positive. So therefore, sine is going to be root 15 on 4. Okay? Because of the region. 0 less than theta less than pi on 2. Because we're constrained to that region, everything's positive. We reject the negative solution. Okay. So then tan is sine on cos. And we've got sine. It's root 15 on 4. And we've got cos. It's 1 on 4. And so we've got these two fractions, one divided by the other. And we could put that in our calculator. Okay. One fraction divided by another, but let's just do some year 8 maths again. A on B on C on D is AD on BC. Okay, so when we have one fraction divided by another, this is an important rule I'll keep talking about, I'll keep using it. So we're going to have 4 root 15. So this is tan theta, that's what we're finding in that. So it's A times D, the top times the very bottom. So we're going to have 4 times root 15, and then B times C, 4 times 1. Now here we have 4 at the top and 4 at the bottom as a product, so we can cancel that. We're left with the square root of 15 on top of 1, which is just the square root of 15, most simply. Okay, so a bit of a fairly long process there to find tan. A couple of moments before we do the next one. Find sine and cos given tan theta is 5. Okay. So with this one, we're going to use the triangle process. All right, and look, you can use whichever one you prefer, any process you prefer. So we're going to start by drawing the triangle, okay? And it has, always can take this shape, doesn't matter. Here's our hypotenuse, adjacent, opposite, okay? Now tan is O on A, right? And you might be thinking, hang on, we don't actually have a fraction there, we've only got 5. Now, any number by itself is always a fraction. It's always itself on top of 1, okay? So then tan is O on A. So we've got O corresponds with 5 and A corresponds with 1. So we've got 5 here and 1 here. Let's use Pythag to find H. We're going to have 1 squared plus 5 squared is H squared. H squared is 1 plus 25, 26. H is plus or minus the square root of 26. Okay, now the question says find cos and tan, find sine and cos, and we're not given a region. Okay, we're not given a region, which means we need to consider both positive and negative values. Well, sine is O on H. So sine is going to be 5 on top of the square root of 26. And we need the plus or minus out the front there because we need to consider both the positive and the negative values. If we go too fast, tell me to stop. Okay, cos is A on H. We get that from here, so that's over. A on H. A corresponds with 1, and H corresponds with root 26. And we need the plus or minus. And we've got both sine and cos. Excellent. So let's see how we go with 5D.1. You can use any process you prefer. It is good to be competent with both. It's good to mix it up, make sure you can get it. Thank you very much.